Hello again, I'm Alan Perwitas from Capstone Partners, and today we're here with Jan Jongboom from Edge Impulse. Welcome, Jan.
Thank you, thanks a lot.
It's a very exciting week for you because you had a big announcement this week.
Yeah, so we formed a company about a half year ago, and yesterday we went live for all developers to start building machine learning models. So we had our launch party yesterday.
But very exciting, I can attest to since I was there as well. So it was a wonderful thing. So tell me about Edge Impulse. I mean, there's a lot of new companies coming in the space, so what do you do that's unique and exciting?
Yeah, so for the past 5 years we've been involved with the guys here from the Things Network and sitting in the LoRa Alliance, and what we saw is that devices, IoT devices, are still very, very dumb. Like they're connected, but if you look at what they actually do, it's very often just sending a temperature value across once an hour. And the reason they do that is because that's the only way you're going to get 2, 3, or 10 years of battery life out of your device. You need to basically be asleep all the time. And that is because sending data to the network, that is a really expensive part. If you don't send any data, then your device will work basically forever. So with Edge Impulse, we want to make these devices smarter by building machine learning models, and developers should be able to do that themselves, to build machine learning models that go on these devices, so do the analysis there, and then you only set the conclusion over. You say, something is wrong with this device, or there's an anomaly detected, rather than sending that raw data, and thus making these devices a lot smarter.
Wow. So a way to think about it then is to say, there's a lot of talk about edge computing.
Yeah.
But edge computing sometimes implies a very heavy edge. And I think what you're doing is actually taking advantage of the processing in a light edge to do heavy decisions.
Yeah, so for us, really, the actual sensor, that is where we want to operate. So a typical IoT device, if you look at the processor in an IoT device, maybe 80 megahertz, 100 kilobyte of RAM, that is what we're targeting. And with our tech, we can do audio models, vibration models, etc., all running on that very sensor. Really the smallest you can go.
Well, that's amazing. I wish I would have had that a couple of years ago. So let's talk about a specific use case. So give me an example of the kind of company that would be a great candidate to embrace this, get this implemented on their edge processors.
Yeah, so just the other day I was talking to a company here actually that is doing pipe monitoring in factories. So there's lots of pipes, steam pipes for example, that all run. And these, for example, in the steam pipe you could have pressure buildup that eventually leads to a loud bang, but that is damaging to that pipe. So by detecting that early, that steam buildup in the pipe early, that means that pipes won't get damaged that easily. And so we can do that based on the vibration pattern in the pipe, because the pipe starts vibrating in a different manner. So it's very tiny vibrations, but that's stuff that we can measure. So industrial things, and our largest customers right now are in consumer electronics. So health wearables, for example, measuring what people are doing and classifying that.
That makes a lot of sense, and the industrial makes a lot of sense too. So right now, there's a lot of analytics going on around vibration, but a lot of the analytics happens back in the cloud.
Yes.
So could I make an argument then that your technology is especially good where there's limited connectivity because you can push all that intelligence to the edge?
Yeah, so still during data gathering phase and when you're actually building a data set, that still needs to happen in the cloud, because we're not at a point where we can actually train new models on these devices. But after that, after you have a model that works, we can scale it down, make it run really, really efficiently, and run it straight at the edge. So the only thing that you got to get is the pressure buildup in my pipe is good, or there's something weird going on, maybe an anomaly, we're deviating from the norm, and that is what you send over the network. That works perfectly over LoRaWAN.
But that makes perfect sense, right? It's just like you have to go to piano lessons to learn the piano, but then after you learn to a certain point, you can play it anywhere.
Yeah,
and it's the same exact thing for the machine learning that you're doing.
Yeah, and what we can kind of leverage here is that training machine learning models is really, really compute intensive. But after that, after I've trained the complete model and give it to you, the only thing you need to do is a few matrix multiplications to get the result. So the inferencing part of machine learning can be done really, really efficiently. So we can do anomaly detection on a data set of vibration data in maybe 1 millisecond per second of data. So that can be really, really efficient.
That's fantastic. And the last thing I just wanted to bring up was you have a very interesting company structure. So you're based here.
I'm based here in Amsterdam. Yep.
Okay, and then you have a presence, of course, in Silicon Valley. So you could just talk about the relationship between those offices.
Yeah, so our headquarters is in San Jose, where Zach, my co-founder, is based. And I'm here in Amsterdam, and actually that works surprisingly well. When I was 2 jobs ago, I was doing 2 years at Mozilla, working on Firefox OS, now defunct, but I kind of learned how you work in a global engineering organization and how nice it actually is to have asynchronous communication built into your company. Because the team that I was working at had people in Taipei, in Amsterdam, and in Silicon Valley, which basically meant there's no overlap at all. And it learns to structure information within your company in a certain way. You make sure you document everything, you make sure that there's chat logs available for everything, and you do the sync whenever people are actually awake. And you have some downtime as well. So every day there's 6 hours where I can work uninterrupted and 2 hours of like heavy syncing with the people in Silicon Valley. And I really love it. So when I was at ARM, we built my team in exactly the same way, also global, and yeah, I'm planning to do that with Edge Impulse as well.
Oh, that's fantastic. So I'm glad to hear that 9-hour difference actually is an advantage versus...
Also, I don't like waking up early, so this is perfect.
So it works out perfectly. Well, Jan from Edge Impulse, congratulations on your launch, and thanks again for being here.
Thank you.